Hi, I'm Blair Reese, and my partner is Joseph Hoffman, and we are studying the thermal conductivity of plaster of Paris. We were designing a heat treating oven that would reach temperatures in excess of 800 degrees Fahrenheit, and we decided to use a wall thickness of 5 inches. We wanted to know if that would be overkill or if it would even be enough. In order to determine that, we needed to know the thermal conductivity of plaster of Paris, which is a constant that hasn't been determined. So we created a block of plaster of Paris and embedded a heating element just under the surface. We attached a multimeter to the heating element in order to measure the heat input through the electricity. And we used an infrared thermometer in order to measure the temperature on all sides. Assumptions that we made are as follows. We assumed that the heat loss through the vise due to conduction would be negligible. We also assumed an emissivity of 0.95, which is used for sheetrock or brick or other porous materials. We also assumed a one-dimensional conduction. The equations that we used are as follows. We used the sum of the heat loss compared to the total heat input. We also used several Musso correlations in order to deal with the shape that we had. And we calculated the thermal conductivity using QL over A delta T for one-dimensional convection. The results that we came to are that the thermal conductivity was about 3.688 for pure plaster of Paris. We decided that further testing is required. The reason for further testing is that we made some bad assumptions, particularly that it would be one-dimensional thermal conduction. In order to correct this, we will be testing a cylindrical specimen with the heating element embedded in the center. We will be using the shape factor as shown below, and that is shown in case 7 in the text. In conclusion, though we know that the 3.688 watts per meter Kelvin is probably not extremely accurate, we were able to determine that the 5-inch wall thickness was overkill. We probably could have gotten by with 2 to 3 inches. If we were to use a block method again, we would test it in an evacuated space. We would use a heating surface, the same dimensions of the contact surface of the material, and we would make sure that the top surface of the material would be smoothed in order to have good contact with the heating element. Thank you for your time.